Okay, so we're going to talk a little bit about the basic concepts of Python. Truly, when it comes to Python, really the best resource is the internet. Just Googling something in Python, you're bound to find what you're looking for very fast, because it is the most popular language, I don't know, worldwide, if not certainly in the States. It's very popular. All right, so we're going to do a brief overview on basic types, containers, files, and functions. So when I mean types, integer, float, string, all that good stuff. Containers, anything that can be in a list. Okay, numbers. Python uses numbers. That's nice. Regular floating point numbers or scientific notation. I'm wondering if here we should just fire up FLAC2D and see if Python, show you how these numbers work in Python. I think that's a good place to start. So I'm going to fire, and you don't have to if you don't want to. I'm going to fire up FLAC2D. Because I've been ranting about Python and all this stuff. Where the heck is it in FLAC2D? How do you use it? I can even use a project. Just starting with a blank slate here. Okay, so you'll probably have noticed, oh, there's a Python tab here. That's nice. And oh, there's a Python console here. So this is Python console is very much like our console. It has stuff in it. So when you install FLAC2D, you also get Python 3.10 install. And this console here is basically an interpreter that's based on Jupyter Notebook that you can use to perform Python tasks. So let's see, you can do one, it's one. Oh my God, it's two. That's very reassuring. So it seems everything will work now as need be. So, so the console, the Python console here is much like our console, where you see your output, test things, and whatnot. So Python is a scripting language. How the heck do we make a script? And I'll show you that here. So let's it's going to be a data file. Data files can be Python files or .dat files. Now I guess it will be, if it opens up here, that's fine. Now you'll see if I just start typing in a file, we'll call it GG. And if I just said, okay, create a new data file, it would be a fish gg.dat data file. If you want it to be a Python script, you have to say .py. And in fact, that's, if you look at the file types, it should be in there somewhere, maybe not. But anyway, you have to say .py. And now you have the equivalent of a data file, which is now a Python file. And you might be, oh, let's just start running it, start making our model. Model new, the first one. Yeah, that's right. Save that. Run it. What? It doesn't know what you're talking about. All the commands, all the fish scripting are not for Python. So this is all Python code. It has to be written in the syntax of Python. And I can see this, that was invalid syntax because it told me in the Python console. All right, we'll come back to writing Python script in a little bit. Okay, so in the console, we could actually just type all this straight up and it would come out, and the output is always this bottom bar. The top box is like input. Few things to note. To square something, or any exponent, I should say, is the 2 stars, and generally it's the caret in fish or in our codes. We have math functionality, much like we have math functionality in fish. Just to remember, whenever you're using these different functionalities, you have to import. You might have to import something, and in this case, it's called math. If you want to get pi, cosine, square root, that kind of fancy stuff. And you can make it even look nicer. You can say from math, which is it's a module that's someone created, but you can import into Python. You can import these different submodules, pi, cosine square root. And instead of basically having math dot, math dot, math dot, to make it look prettier, just pi cosine square root. That's all we want it to look like. This is commonly done in Python. It's like the first few lines, you import all the things you're going to use. You're going to make it easy for yourself by importing, in this case, pi cosine or square root. And then when you start typing your code, it's going to be very clean and reduced. It's not going to have all these math dot cosine dot inverse, whatever you might have to. And so we'll talk about importing modules. We have a module called ITASCA. And when you import that ITASCA module, then you get everything you've basically learned up to this point. You can then type commands. You can access fish variables, access fish. So yeah. A lot of people like to call it something different. So you import ITASCA and they're going to say as IT. It's just, you don't have to. People do it for shorthand. ITASCA is not just, the ITASCA module is not just simple things like one zone or a structural element. You can import an entire list of things. And this particular piece of code here is from PFC. So in PFC, you have a bunch of balls, thousands of them, and you can import a module called ball array, and it is an array with all the addresses of these of every single ball. So the best way to use this kind of array is, say you want to operate on all balls in the array. You can just use the ball array instead of looping through every single ball and doing something to it. This is very similar to NumPy arrays. So yeah, avoid this. Apparently this was some old Python syntax where people would use the star. But so just don't do it. I've never even used it. All right. So we talked about numbers, importing modules, and strings are, a very common thing in any language. You can have strings in Python. And these triple quotation marks are kind of a way you can give a character return without breaking out of the string until it reaches the last triple quotation mark. We use that a lot because it's a nice way to issue a command on each line, and we'll look at that in a little bit. Strings are actually can be added together. A lot of times strings can't do that in other codes. Python is really handy with string manipulation. And in fact, the string manipulation in Fish doesn't come close to what Python can do. You can do type conversion. And I think actually this is the same syntax as Fish uses, where if you want to change a type, you just say integer, give me the type, change it to an integer. String, give me the type, change it to string. Don't get too worried about this split. This is not splitting like you were just shown in Fish. This is just, like I said, Python has a lot of things it can do with strings and lists of strings. And join strings. And you can do all sorts of string manipulation. So you can loop through strings, you can find something in the string and do stuff to it. We're not going to get into it. Jason is the brains behind Python and FLAC2D, so that's why he's doing all the my name is Jason stuff. Okay, and you can set variables. So you have these 3 variables right here that you set: ratio, zone, ID, stress. And you can do the special thing where you have place markers in your string, and that's where those variables will go. The only reason we bring that up is because we do it a lot for when you issue a command in Python. We have variables that might be defined outside of the triple quotation marks, and then we want those variables to be inside our triple quotation marks. And this will be best illustrated right here. So primarily when we run through an example, this is what you'll see. Import ITASCA as IT. This is a handy way to create 3 variables on one line in Python. Size X is 10, size Y is 20, size Z is 10. Okay, and then let's build a model like we have been doing. In Python, this is how you do it. You have to start with IT, which actually stands for ITASCA, .command. And then you issue your commands like you would in your data file. So you've seen these, model new. This is a little different, the size here, but you've seen zone, create brick. You've seen zone, C model sign elastic, and the properties. Those little placeholders, X, Y, Z, are so you can get this data out here, the size X, size Y, size Z, and basically input it into your command. So using the dot format sequence, you can say X here will now, the X here will now equal 10. Well, the Y right here will now equal 20, and the Z will now equal 10. Which, looking at that makes no sense in 2D. For obvious reasons, it would just be X and Y. Got to change that one.